Doculabs has developed a process mining application for marketing and creative organizations that use Adobe Workfront. The application enables organizations to quickly identify inefficiencies in the creative asset development and approval process, such as rework and wait time resulting in missed SLAs. Today, we're going to walk you through the analysis we've created using a client's Workfront activity history. Our objectives are to show you how we are able to quickly identify process inefficiencies and identify improvement opportunities. This tool will enable a client's marketing function to free up additional capacity so it can absorb the additional volume of work requests without adding headcount and costs. Let's take a look at what the Workfront environment typically looks like. The first section is the work list, where users complete and the log and tasks assigned to them. Under scenarios, you can see the project plan over several months. Finally, under the reports, you can see how the project is progressing. Now let's look at the Workfront data after it has been loaded into Celonis. We've loaded the October 2021 activity history from Workfront into Celonis. Doculabs configured Celonis specifically for a client and created a number of example analyses to help you envision the world of the possible. There were 7,500 projects completed and 4,300 different proofs entered into the system during the month of October. There are a number of different tabs across the bottom, each containing a different view of the data. In the first tab, you'll see a tool called Variant Explorer. This allows us to visually see the different process paths the work followed and investigate the different aspects, such as the number of work items per path, the time between each step. Here we begin to get a feel for where the bottlenecks are occurring. For example, here we are simulating the work going through the most common path. Now the fourth and fifth most common, as you can see here. Unfortunately, we see that just 18% of the jobs flow through the top 5 paths. A healthy, well-designed process tends to be upward of 60%. In total, there were 2,100 different ways work was processed. Remember, there were just 4,300 different jobs. Now let's look at the ugly underbelly of the other category as I zoom in to see that there's far too much variation in the process. Now let's move on to one of the 4 dashboards. First is cycle time. Across the top, there are 3 primary KPIs we focused on: estimated duration, actual duration, and the amount of actual work needed to complete the job. Note, duration is in days, work is in hours. Right away, we can see that the portion of actual work time to the duration time is less than 20%, a bad indicator. This means that the majority of time needed to complete a job is wait time or latency, waiting for the next resource or step. On the left are a number of drop-down selectors. These are a means to filter the data quickly to look at different subsets of jobs or employees or types of tasks. The second is resource analysis. Similar capabilities are shown here. For example, we can see that Alexa spent over 12 hours on each video, which is much higher than her peers. We click on video, we can compare to see that her peers are able to complete it in much less time. This may be due to overassignment or mismatches in skill that could be resolved with better rules regarding work assignment. The third is the benchmarking tool. Here we see a common approach to comparing 2 different time periods. And the final fourth analysis, the proofing of data for rework. Here we see there is an entirely different data set that we will need to work together to ensure consistency with the project data. What we've done is redefined work as any activity that was repeated more than once. For example, draft, proof, approve equals no rework. Draft, proof, approve equals rework. Here we see that using this definition, approximately 15% requires rework. We expect there are a few items or terms in the data set that would also indicate rework, but we have a very literal interpretation for now. So when we used $100 an hour cost to the actual rework effort, we see that there was over 1.4 million of rework in the period. In addition, we would refine these calculations and put an alert in place, allowing supervisors to take action in real time to reassign or diagnose what the problem might be. In summary, we've shown you the analytic power that process mining brings to the client, enabling it to increase capacity within the existing resource pool to address the anticipated growth as you go forward.